How to build a quality closed crawl space in climate zones 3A and 4A. This program presents the latest information on methods and materials for building a closed crawl space that is dry, durable, energy efficient, and provides a comfortable main floor. A companion tech spec provides more specific details and a broader range of construction options. This information was developed to improve the quality and performance of current crawlspace designs and to assist when considering the benefits of switching from a slab-on-grade to a crawlspace foundation. Note that all applicable local building code requirements and all specifications established by the licensed professional for the project must be followed. Unlike a conventional vented crawlspace, a closed crawlspace does not have wall vents and is air-sealed to improve energy and moisture performance. A closed crawlspace includes insulation on foundation walls, a ground vapor retarder, and mechanical ventilation. Some local jurisdictions allow floor insulation instead of wall insulation. A closed crawlspace may also be referred to as unvented, conditioned, semi-conditioned, or sealed. Wall-vented and open crawl spaces are not covered in this program. Closed crawlspace construction begins by building a foundation wall on top of a poured concrete footing. Common wall materials are poured concrete, masonry block, or wood framing. Selection is based on cost, local market preference, and skill of available trades. While 8-inch thick foundation walls are common, 6-inch walls, concrete or fully grouted masonry, are allowed by code for many crawlspace applications. 2x4 or 2x6 wood frame walls are particularly popular on sloped sites where cripple walls are used in combination with stepped concrete or masonry walls. The International Residential Code does not specify a minimum crawlspace height. Height is controlled by practical factors such as curb appeal, water table, storage, or access to mechanical equipment. Like other foundation systems, measures for keeping exterior moisture from getting inside the crawl space include proper site grading, an exterior drainage system, and damp-proofing the exterior surface of the foundation wall. Best practices include the use of gutters and downspouts to direct water away from the house, roof overhangs, and an additional interior drain system with a sump pump. A Class 1 vapor retarder must be installed over all exposed earth to minimize ground moisture in the crawl space. A 6 mil thick sheet of polyethylene is the minimum required by code. The earth should be cleared of all vegetation and organic material before installing the vapor retarder. All seams are taped and the edges are sealed to the foundation walls or wall insulation, providing a continuous moisture barrier. The poly can also be capped with a 2-inch non-structural concrete slab. This slab adds durability by protecting and sealing the poly and serves as a clean, usable floor. The two primary factors that impact the energy efficiency of a building enclosure are air sealing and insulation. In a crawl space, air sealing is applied at the sill plate, rim joist, and at all penetrations through the exterior walls and framing. With stepped foundations, joints between the edge stud and the vertical concrete surface should also be air sealed. A closed crawl space is typically insulated by installing insulation on the interior of the wall. Where continuous wall insulation is used, the 2012 IRC requires a minimum R5 in Climate Zone 3 and a minimum R10 in Climate Zone 4. Wood-framed cripple walls and the rim are generally insulated to the same level as the above-grade framed walls. A range of insulation products are available, including fiberglass, rigid foam sheathing products, and closed-cell spray foam. Spray foam insulation has the added benefit of providing a good air seal. Rigid foam sheathing and spray foam must comply with specific fire safety criteria, including ignition barrier and thermal barrier requirements. Foam manufacturers offer specific products rated for exposed applications in both rigid and sprayed types that can be used without additional fire protection. Factors that impact fire rating include insulation type, insulation thickness, and whether or not the crawl space is used for storage. The IRC exempts spray foam up to 3.5 inches installed at the sill plate and the rim joist from the thermal barrier requirement. In climate zones 3 and 4, an interior vapor retarder is not required by code on either framed or solid crawlspace walls. If fiberglass insulation is installed against the foundation wall, the facing material on the interior surface should be perforated or vapor permeable to avoid trapping moisture. To limit moisture from the foundation wall entering the conditioned crawl space, rigid or spray foam insulation, a sheet of poly, or both foam insulation and poly can be installed directly against the wall. As an added benefit, foam insulation helps keep the interior surface warmer, reducing condensation potential. The floor can be framed with dimension lumber joists, wood trusses, or wood eye joists, all sized and spaced based on the span. Where additional sturdiness in the floor is desired, shorter spans, deeper members, and closer spacing can be considered. Subfloor panels, rated for the application, should be both nailed and glued to the floor joists to prevent squeaks. Subfloor panels should be spaced 1/8 inch to accommodate panel expansion. Panel edges may need to be sanded before installation of the finished floor, but many subfloor manufacturers carry products that have a no-sand guarantee. A closed crawl space provides a more suitable environment for ducts and mechanical equipment than a conventional vented attic or vented crawl space. Temperatures in a closed crawl space are more stable, resulting in reduced energy loss and reduced condensation potential. Also, locating ducts and mechanical equipment in dry and enclosed space helps maintain good indoor air quality in the house. Also, crawl spaces provide easy access for the trades to install ductwork. Similarly, the water heater and plumbing piping may be installed in the closed crawl space. To control humidity, the IRC requires either continuous exhaust or conditioned supply air at 1 cubic foot per minute for each 50 square feet of crawl space floor area. A transfer grill or duct connecting the house to the crawl space is also required to balance airflow. As a best practice, exhaust ventilation can be used to minimize air exchange between the crawl space and the main floor. Following practices presented in this program and in the companion tech spec will result in a crawl space that is dry, durable, energy efficient, and provides added value to both the builder and the homeowner. The closed crawl space videos and the companion tech spec are available on the Home Innovation Research Lab's website at www.homeinnovation.com. The development of these videos and the companion tech spec was supported in part by the Southern Forest Products Association.